Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and we're going to sit here today and talk about Unit 10, mini lesson number 5. We're going to talk about tree diagrams that we can use to solve for compound probability today. By the end of today's lesson, you should be able to explain how to make and use a tree diagram so as to better help yourself find compound probability. But Mr. Allred, what is compound probability? Well, the truth is a compound event is any two or more events happening at the same time. Okay? Best example I can give you is tossing one die is a simple event, but if you toss two dice at the same time, that's a compound event. Okay? For example, we're going to make our first tree diagram right here. If 3 coins are tossed, what is the probability of getting exactly 2 heads? Okay, I want exactly 2 heads out of my 3 coin tosses. And what I'm going to do is that's 3 different events happening at once. To calculate that probability, we need to know how many total outcomes there are. And then we will use that tree diagram to help us. Okay, Parvert's already started for you. We'll complete the rest of the tree together. Here you go. What I usually do is I will section my tree diagram off by the first coin flip, the second coin flip, and the third coin flip. Okay, so it's sectioned off right there for you. Really lovely. Right there for you on the page. Okay, and then we'll list the outcomes. The first time you toss it, 2 things could happen. You could get heads or tails. That's represented right here by the heads and by the tails. Okay, then you can see these branches. This is why it's called a tree diagram. You are going to draw branches to the next coin flip. Okay, so if you got heads the first time, there's 2 things that could happen the second time. You get heads or tails. That's represented right here. Okay, this would be like getting heads twice in a row, heads, or they're getting heads and then tails back to back. Okay, if the first time you toss it, you got tails, the second time you toss it, 2 things could happen. You get heads or tails. See how I'm listing these different possibilities with these branches. Okay, I could have gotten heads and heads, or heads and tails, or tails and heads, and then tails and tails. Those are the 4 things that could happen so far. The third time I toss it, if I've gotten heads and then heads, the third time I toss it, I might get heads, I might get tails. So I've listed that 2 options there. There's 2 different outcomes. You can get heads 3 times in a row, or get heads twice in a row and then tails. Those are the 2 options, the 2 outcomes. Okay. If I got heads and then tails, the third time I toss it, I could get heads or tails. I've listed that there for you. So I could have gone heads, tails, heads, or heads, tails, tails. I've listed those 2 different outcomes there. Okay, so far I have 4 outcomes if I got heads first. If I got tails first, I can go heads, I can go tails, heads, heads, or tails, heads, tails. That's listed there with those 2 outcomes. Tails, heads, heads, or tails, heads, tails. You try to say that 5 times fast and see what happens to you. Okay, or I could have gotten tails and then heads, or tails and then tails and then tails. Those are my 2 other outcomes at the bottom. Tails, tails, heads, tails, tails, tails. The question asked us, what is the probability of getting exactly 2 heads, getting heads exactly twice? Okay, so here you go. The probability of getting exactly 2 heads out of 3 coin tosses will be the number of tosses with 2 heads out of the total number of outcomes. Okay, we're about to figure out what that is as soon as I get rid of this. Okay, if you count the number of times that you got heads exactly twice, that means I can't count the first one, that's heads 3 times, but I can count this one, 1, 2, 3. Those are the 3 times that I got heads exactly twice, okay, for a grand total of 3 times, 3 outcomes that I liked out of 8 total outcomes. 1, 2, 3, 4, 5, 6, 7, 8. So there's a 3 out of 8 chance that if I toss a coin 3 times, I get heads exactly twice. 3 out of 8 chance. Okay, we just made our first tree diagram together. Congratulations. Okay, here is another example. If you had 4 bottles of soda, 1 bottle of cola, 1 bottle of root beer, 1 bottle of ginger ale, and 1 bottle of orange drink, you're going to choose 3 of those bottles to take to a party. Okay, it says if she chooses ginger ale, so we know she's choosing ginger ale. This might be kind of like one of Miss Mercer's logic puzzles. What is the probability that she chooses root beer 2? So what is the probability that chooses root beer 2? As you can see, this tree diagram, it's a little different because it says she does choose ginger ale. So you can see that my first choice, I went ahead and chose ginger ale 4 because we knew she was going to choose ginger ale. She only has one bottle of ginger ale, so there's only 3 things she could pick next: a cola, a root beer, or an orange drink. If she picked ginger ale and then cola, she could only pick root beer or orange drink third. So she could go ginger ale, cola, and then root beer, or ginger ale, cola, and then orange drink. Okay? If she chose ginger ale and then root beer, there's only 2 things she could choose next. She could choose cola or orange drink. So she could go ginger ale, root beer, cola, or ginger ale, root beer, orange drink. Okay? If she chose ginger ale and then orange drink, there's only 2 things she could choose next. She could choose root beer or cola. So she could go ginger ale, orange drink, and then root beer, GOR, or ginger ale and then orange drink and then cola. Those are all the possibilities. There's only 6 total outcomes. The question says, what is the probability that she chooses root beer 2? If you count up the number of outcomes with an R, you got 1, 2, 3, 4 outcomes with an R. So it makes sense that there's 4 outcomes that I wanted with root beer out of 6 total outcomes. Okay? There was a 2 out of 3 chance that if she picked drinks at random and she chose ginger ale first, there's a 2 out of 3 chance that she would choose root beer 2. Okay? That's how tree diagrams work. We draw those branches and we list out the different possibilities. At the end, when I've made all my choices, I can list the outcomes here on the side like I have right here. Okay? That shows us that there's 6 total outcomes. Okay? On the right side of your page, you see 2 different examples, I believe. Okay? Making a sandwich and having children. All right? That's what we're going to look for there in the next example. I'm going to help you with those on my station. Okay? Thanks for watching this video about compound probability and tree diagrams. Have a great day. Make it a great day or not. The choice is yours. Thank you.